Myself, Nazira Sultana, e-content developer, LMS team, welcome all the students and viewers. Today's session is for the course Switchgear and Protection of 5th semester Electrical and Electronics Diploma Engineering. Today's topic HRC fuse is from Unit 2 Fuse and Circuit Breaker. Before starting today's session, let us try to recapitulate what you have studied in the previous sessions. You would have learnt about fuse, fuse element, desirable characteristics of fuse element, commonly used materials for fuse element, important terms used in the analysis of fuse, types of fuses. Today's topic HRC fuse is a type of fuse. Hence, we'll try to recapitulate more about fuse. Let us try to see what is a fuse. A fuse is a simplest protective device. Why do we say this? Because there are other protective devices such as circuit breakers, relays, etc. Compared to them, fuse is simple in construction and simple in working. That is the reason why we call fuse as a simplest protective device. It works on the principle of current interruption if flowing current becomes excessive. Let us try to understand this. So we know that usually fuses are used as a protective device in the circuit. So when the circuit is healthy, normal current flows through the fuse. Fuse will not get overheat and hence your normal working will take place. Once a fault occurs, as soon as the fault occurs, the current value rises to an abnormally high value. This high value of current starts flowing inside the fuse. As soon as this high value of current starts flowing in the fuse element's temperature increases and it becomes more than its melting point and hence the fuse element breaks open. Once the fuse element breaks open, it will cut open the circuit into an open circuit. That is the reason why we call it as a current interruption device, or it works on the principle of current interruption. Once it opens up the circuit into an open circuit, it clearly separates the circuit into a healthy part and a faulty part. Its construction is and working is simple. As just now I told you when I was explaining about the simplest protective device, its construction and working is simple. Fuse is always connected in series with the circuit or appliance to be protected. Why should we connect the fuse in series? Because if we connect the fuse in some other pattern other than series, once it heavy current flows, once it breaks open, it cannot open circuit the circuit. That is the reason why we connect the fuse in series. Now let us try to recapitulate more about fuse element. So what is a fuse element? Fuse element is one of the most important parts of a fuse. It is nothing but a small piece of metal. So once we say this, can we use all the metals as fuse element? No, it's not possible to use all the metals as fuse element because they should have certain desirable characteristics. Let us try to see what are those desirable characteristics. The fuse element should have low melting point. They should have high conductivity. They should be free from deterioration due to oxidation and they should be of low cost. If a metal has all these characteristics, then we can use such metal as a fuse element. The most commonly used fuse elements are silver, copper, tin, alloy of tin, lead. Even sometimes zinc is used as a fuse element where time lag is required. Now let us try to see the classifications of fuse. Fuses are classified into low voltage fuses and high voltage fuses. Low voltage fuses are further classified as rewirable fuses and your HRC fuses. High voltage fuses are classified as your cartridge type fuse and liquid type fuse. These are the classifications of fuses. Now coming to this today's session, let us try to see the contents of today's session. Today, we will be looking into the topics HRC cartridge fuse, that is nothing but high rupturing capacity cartridge fuse. Later, we'll be seeing the advantages and disadvantages of HRC fuse, then applications of HRC fuse and difference between a fuse and a circuit breaker. These are the four topics what we'll be discussing in today's session. Let us try to see what is a HRC fuse. A HRC fuse is nothing but high rupturing capacity cartridge type of fuse. This is one of the simplest form of fuse used as a protection device for distribution purpose. So it is one of the simplest protection what we are using in the distribution power systems. It provides reliable discrimination and accurate characteristics. So let us try to understand what does this mean. So when I was explaining you the principle of fuse, I told fuse will melt and it break open the circuit. That means its work is to break open the circuit and separate the healthy part from the faulty part. So HRC fuse also is doing the same work. So it is discriminating. So how it is discriminating? Reliably. Reliably means you can trust it will do its work promptly. So that is why we say it provides reliable discrimination and accurate characteristics. So for whatever rating it is designed, for whatever settings it is being designed, it will work as per that in a perfect way. That is why we say it provides reliable discrimination and accurate characteristics. The low and uncertain breaking capacity of semi-enclosed fuses is overcome in the HRC fuse. So we have compared a HRC fuse with the semi-enclosed fuse. When we compare it, it clearly tells us that HRC fuse has got an upper hand over the semi-enclosed fuses. The disadvantages what we had in the semi-enclosed fuse, such as uncertain and low breaking capacities, are overcome in the HRC fuses. Right? So this is regarding your HRC fuses. Let us try to see the classification of HRC fuses. HRC fuses are classified into cartridge type and liquid type. This sketch shows the cartridge type of HRC fuse. This image shows the liquid type of HRC fuse. Liquid type of HRC fuses are used for high voltage applications. Let us try to understand the HRC fuse characteristics. So what are these? So this graph shows us the HRC fuse characteristics. So when you look at these characteristics, you can see on the x-axis time in seconds is marked and on the y-axis current in amperes is marked. The time in seconds is marked as 0.01. The meaning is 0.01. From 0.01 to 4 seconds, we have marked the values on the x-axis, and current is marked on the y-axis starting from 100 to 1400 amperes. So when we plot the graph of time and current, we get the curves. You can see three different curves here. These three different curves are for three different rating fuses. The first one is for a 60 amp fuse, the second one is for a 100 amp fuse, and third one is for a 200 amp fuse. Let us try to analyze the characteristics. We'll take one curve and we'll try to understand. Let us take this curve which is for 60 amp fuse. When you look at this curve, when you look here, it is somewhere around 650. So when the fault current is around 650, when you look down on the x-axis, the value of time is 0.01 second. This tells us that if the fault current is 650 amperes, then the time required for the fuse to interrupt is 0.01 second. Now let us try to see the next point. Let us take this point. It is more clear. So when you look at this point, so here when you see when the fault current is 300 amps, the time required is 0.03 seconds. So this tells that when the current was 650, fault current was 650, it took 0.01 seconds to interrupt the fault current. When the fault current was 300 amps, it took 0.03 seconds to interrupt the fault. So this tells us as the fault value keeps on increasing, the time required to interrupt is less. So why is this characteristic like this? Because whenever the fault is more, the damage caused will be huge. That is why if there is a heavy serious fault, if it interrupts at a faster rate, the damage caused to circuit will be less. If the fault is of a smaller value, if it takes little more time also, the damage caused will not be so severe. That is the reason why we have this type of characteristics. As the fault value increases, the time required will become less. Hence, this type of characteristics is called as inverse time current characteristics. These type of characteristics are suitable for overload protection. So, HRC fuses have inverse time current characteristics. Now, let us try to see the construction and working of HRC fuse. This sketch shows us the parts of a HRC fuse. Once you look at this sketch, you can see you have an outer cartridge, then you have a center fuse element which is fixed on the outer elements. To this outer elements, a brass end cap is fixed, and in between the cartridge and the fuse element, you are having these dots. These dots show us or indicate the filling powder, and you have got a fuse link contact to connect the fuse to the inner circuit. So these are the important parts of a HRC fuse. Now we'll try to understand the construction of a HRC fuse. So HRC fuse consists of a heat resisting ceramic body with metal end caps. Just now I told you the cartridge, it will be usually made up of heat resisting ceramic body with metal end caps and silver current carrying element. So the fuse element what we are going to use is, it will be made up of silver and it is welded to the metal end caps. Now the space between the ceramic body and the silver element is covered with the filling powder. So what is this filling powder? It is usually chalk, plaster of Paris, quartz or marble dust. The filling powder what we use is, it has got a specific function. It will act like a arc quenching and cooling medium. This is the work of the filling powder. So this constitutes your construction of HRC fuse. Now let us try to see the working. So I told you fuse is present in the circuit in normal condition as well as in faulty condition also. So let us try to see how it works when the system is healthy or when the circuit is in normal condition. Under normal load conditions, the fuse element is at a temperature below its melting point. Therefore, it carries normal current without overheating. So when the system is healthy, the normal current flows through the circuit and the same normal current tries to flow to the fuse and then to the circuit. So fuse temperature will be below its melting point. Hence, there will be not be any overheating. Only normal heat will be produced. But what happens when the fault happens or when the condition becomes abnormal? So when the fault occurs, the current increases and the fuse element melts before the fault current reaches its first peak. So we know that as soon as the fault occurs, the current value rises to a very high value, abruptly to a very high value. As soon as the current rises to a very high value, the fuse element temperature will become more and it melts. And it melts such that the fault current value just before reaches its first peak. It melts and breaks open the circuit and safeguards the circuit, and it separates the circuit into a faulty part and a healthy part. Now, once the temperature of the fuse element increases, it melts and breaks down and the fuse element will start vaporizing. So the silver fuse element which was there, it converts itself into now silver vapors, and inside the fuse you are having a filling powder. So the chemical reaction between the silver vapors and the filling powder results in the formation of high resistance substance. So what happens? There will be a chemical reaction between silver vapors and the filling powder. Hence, a high resistance material or substance is produced which will quench the arc. Quench ಅಂತಂದ್ರೆ ನಂದಿಸುವುದಂತ. It will quench the arc and the arc is put off. Once the arc is put off, the further damage caused circuit is reduced. This is how your fuse will make the faulty circuit into an open circuit and separate the faulty part and the healthy part, and it will not allow the fault to spread to the healthy part. The fault gets localized. So next we will try to see the advantages of HRC fuses. So what are its advantages? HRC fuses are capable of clearing high as well as low fault currents. I told you when the system is healthy, it is working normally. When the fault occurs, it breaks open the circuit. Now the fault can be small fault, that is we call it as incipient fault, or it can be a huge fault which we call as a serious fault. If the fault is incipient or it is serious, it will work reliably. That is why we say it is capable of clearing high as well as low. That means it will break open the circuit and it will clear. For example, you are having a 200 amps fuse, we'll imagine. Now, if 210 amps of current flow in the circuit, fault has occurred because 10 amps extra current is flowing. If 300 amps of current flows, that time also fault has occurred. But the intensity of the fault is varying here. When it is 210, the fault is a incipient fault. When the fault current is 300, the fault is more serious than that. So in both the cases, the fuse will do its work. What it will do, as soon as the fault current flows, it will melt and break open the circuit and it will separate the faulty part and the healthy part. That is why we say it is capable of clearing high as well as low faults. Second advantage is do not deteriorate with age. Now what is this deterioration? Losing its quality, or from its standard value it is dropping down. So it will not happen with age. That is, suppose you have bought a fuse, you have it is in the circuit, but it has been not operated for quite some times. After 6 months or 8 months, it comes into operation. We'll imagine that time also it will do its work. What is its work? Its work is to, whenever the fault occurs, it has to melt and break open the circuit. So it will do its work. Why it is doing? Because its qualities are not come down, its properties have not been lost. That is why we say do not deteriorates with age. Next, third advantage is high speed of operation. When I was explaining the working of the HRC fuse, I told you as soon as the fault current flows inside the fuse, the temperature of the fuse element becomes more than its melting point. Hence, what happens? It breaks open and separates circuit. So this is so quick. That is the reason why we say the speed of operation is very high. It will not take much time to separate the faulty part from the healthy part. Next, it provides reliable discrimination. So once it makes the circuit into an open circuit, it is clearly making the circuit into two parts, one healthy part, one faulty part. So it is providing a trustful discrimination. Next advantage is requires no maintenance. So once the fuse is operated, it melts and blows off. So there is no question of maintenance. You cannot repair it. Once it blows off, you have to remove it and replace by a new one. The further advantages are it is cheaper than other circuit interrupting devices of same breaking capacity. So other interrupting devices, circuit interrupting devices are like your circuit breaker. They are also your protective device. But compared to them, fuse are cheaper for the same breaking capacity. HRC fuses performance is consistent. So consistent means it remains same. It will not change. One time it works, one time it doesn't work. It's not like that. It is doing its work sincerely, properly all the time. That is why we say the performance is consistent. So these are the advantages of HRC fuse. Coming to the disadvantages of HRC fuse. They have to be replaced after each operation. I told you once the fault occurs, once they are into operation, they melt and break. Right? Once they are broken, we cannot repair. We have to remove and replace by the new one. So every time this you have to do. So it is a disadvantage. Heat produced by the arc may affect the associated switches. So when the fuse melts, right, and breaks open, there may be small amount of arc. This will affect the associated switches. Then interlocking is not possible. Interlocking is a common phenomenon in industrial procedures and processes. So it is not possible with HRC fuse. So these next is applications of HRC fuse. Now we'll try to see where are these HRC fuses used. The HRC fuses are used to protect low voltage distribution system against overload and short circuit conditions. So we use these HRC fuses in the distribution system, power distribution system, where you have to give protection against overload and short circuit condition. When I was explaining you the characteristics of HRC fuses, I told you that HRC fuse has got a inverse time current characteristics. So these characteristics are used for overload protection. That is the reason why HRC fuses are used in your overload and short circuit condition. Second application is they are used for backup protection to the circuit breaker. So circuit breakers are also protective devices. So when they are used, suppose due to some reason they are not able to work or there is a failure of their working, that time fuses can be used as a backup. So they will take the charge of the circuit breaker and they'll try to work just like a circuit breaker, which is nothing but your current interruption during fault. So next application is they are used for protection of transformers, motors and automobile electric wiring circuit. They are even used in motor starters. So these are the applications of HRC fuses. Now we will try to see the difference between fuse and circuit breaker. Let us first try to understand why should we study a difference between a fuse and circuit breaker. Because fuse and circuit breaker both are current interrupting devices. Fuses interrupt small value of current, whereas circuit breakers are used for a higher value of current. But both do the work of current interruption during the fault. Let us try to see the difference between fuse and circuit breaker. The first difference we have taken under the category function. So function wise, what is the difference we have in fuse and circuit breaker? So when you look at fuse, it performs both the detection and interruption function. Whereas in a circuit breaker, it performs interruption function only. The detection of the fault is done by relay. We'll try to analyze this. So I told you when the fuse in the circuit, when the circuit is normal, healthy, the current will flow through the fuse, no overheating takes place. Whereas as soon as the fault occurs, the heavy current tries to flow into the fuse which is above its melting point, and hence the fuse element melts and break opens and it opens the circuit. It makes the circuit into an open circuit. That means it by itself it is interrupting the process and itself it is detecting the fault. Here nobody is telling the fuse that fault has happened, you do your work. So as soon as the heavy current flows inside the fuse, it will by itself it will detect and it will break open the circuit. That is why we say it performs both detection and interruption function. Whereas in a circuit breaker, it does only the interruption function. Detection is done by your relays. So relay is a sensing device which will sense the fault and it will give a information or a signal to the circuit breaker. How it does? So when the fault occurs, the relay will sense the fault. It will generate a trip signal to the trip circuit. The trip circuit mechanism of the circuit breaker will open the contacts of the circuit breaker. So hence function wise circuit breakers perform only interruption function. The detection of the fault is done by the relay. So the next difference is operation wise. Operation wise, let us see what difference they have got. Fuses are inherently completely automatic. Circuit breakers require elaborate equipment for automatic action. What does this mean? Fuses are inherently means naturally. Once the fault occurs, they themselves analyze the fault, then break open the circuit and they separate the circuit into faulty part and a healthy part. So everything is done naturally and in an automatic way. Whereas circuit breaker, it is not so. Relay is the first device which senses the fault, then it generates a trip signal, and then the circuit breaker does its work. If you want to make the circuit breaker into automatic action, then you require many number of other devices and other equipments which have to be fixed along with the circuit breaker to do this automatic action. So this is the difference operation wise. Fuses are inherently, means naturally, completely automatic. Circuit breakers require elaborate, means large number of and big, that is thing, requires elaborate equipment for automatic action. Let us try to see the next difference. Breaking capacity wise, fuses have got a smaller breaking capacity, whereas circuit breakers have got larger breaking capacity. So fuses breaking capacity is small. Now let us try to see what is this breaking capacity. It is nothing but the current that a fuse is able to interrupt without being destroyed or without causing any damage to the electric circuit or the whole circuit. That is called as a breaking capacity. So breaking capacity of fuse is small, whereas breaking capacity of circuit breaker is large. Coming to the operating time, fuse has got a small operating time, whereas your circuit breakers have got comparatively large operating time. Why is this? We'll try to understand. Fuse, I told you, as soon as the fault occurs, the heavy current flows to the fuse and fuse will open circuit the circuit. So it doesn't require much time. The standard value usually is 0.02 seconds to interrupt the fault. Whereas circuit breaker relay is the device which will sense the fault. Then it will give a signal to your trip circuit or generates a trip signal for the trip circuit. The trip mechanism will work, then the circuit breaker contacts will open. So all these things to happen, it requires little more time. The range of time required is 0.1 to 0.2 seconds. So operation time wise, fuses are more faster than your circuit breaker. And the last difference regarding your fuse and the circuit breakers are replacement. I told you, once the fuse is in operation, it blows off. So there is no question of repair or maintenance. You have to just replace by a new one. So it requires replacement after every operation. Whereas a circuit breaker doesn't require any replacement. After each operation, it can be used. These are the few differences between fuse and circuit breaker. So these are the topics which we are supposed to cover in today's session. I hope all the topics are clear. Before going to our assessment part, let us try to summarize what we have learned today. We first saw the preview of the previous session, that is what is a fuse, what is a fuse element. Then we came to today's session. We learned what is a HRC fuse. Then we understood its construction working. Later we saw the advantages, then the disadvantages, then the applications, and then the differences between fuse and circuit breaker. So the important points what we have to remember regarding fuse is that fuse is a simplest protective device. Even HRC fuse is also a simplest protective device which can be used in the distribution side. Its working is simple, its construction is simple. Coming in the working, when you look at the working, it does an current interruption in a faster way when compared to your circuit breaker. In particular, if you want to see the working of the fuse, so when the system is healthy, normal current flows through the fuse which is below its melting point. Hence, the fuse element will carry the normal current without overheating. But when the fault occurs, as soon as the high value current flows into the circuit and through the fuse gets heated up, which is above its melting point, and it breaks or it melts. So once it melts, it is going to make the circuit into an open circuit. Because of this, lot of amount of heat is generated. Now this heat will vaporize the fuse element, which is usually made up of silver. The silver will become into silver vapors. So these silver vapors and the filling powder which is around this element will have a chemical reaction and a substance produced which is having high resistance, right? That is the reason why your arc which would have been appeared during the fault will be quenched, and then your heat will also be reduced. So your filling powder does the two work. One is quenching of the arc, other one is cooling the medium. So this is how your fuse works. Right? So next we saw the advantages, we saw the disadvantages, we saw your applications and differences between the fuses and circuit breaker. I hope today's session is clear. Let us try to see how much we have understood today's session by answering this small assessment in the form of MCQs, multiple choice questions. Let us take the first MCQ. HRC fuse are used as dash protection to circuit breakers. Options are primary, backup, secondary, first line. The answer is option B, backup. When I was explaining you the regarding the HRC fuse, I told you HRC fuse are used as a backup for circuit breakers. If any case, if the circuit breakers are not working, if they are under a faulty condition, or suddenly if they are not able to perform their function, then HRC fuses will take the charge of the circuit breaker. They do the same function what the circuit breaker does. That is why they are used as a backup. So your answer should be option B, backup. Let us move to the next MCQ. The filling material used in HRC fuse is option A, chalk, option B, plaster of Paris, option C, quartz or marble dust, option D, any one of the above. When we are understanding the construction of a HRC fuse, I told you the filling powder what we use in the HRC fuse is either chalk, plaster of Paris, quartz or marble dust. So your answer should be option D, any one of the above. Any one of the above you can use. Now let us try to see the next MCQ. The outer body of HRC fuse is made up of option A, ceramic, option B, rubber, option C, plastic, option D, none. So I told you when we were discussing about the construction of the HRC fuse, the outer body is heat resistant body and is usually made up of ceramic. So your answer should be option A. Coming to next one, the fuse element of an HRC fuse is made up of option A, gold, option B, silver, option C, bakelite, option D, rubber. So when we look at the option C and D, C, bakelite is a good conductor of heat, whereas rubber, D option is a insulator. So those two options are ruled out. It can't become fuse element. The first option, gold and silver, out of these two options, option B, silver is the most commonly used fuse element in an HRC fuse. Coming to next MCQ. In HRC fuse, under normal load conditions, the fuse element is at a temperature dash its melting point. Option A, above, option B, below, option C, exactly at, option D, none. So I told you under normal condition the temperature is below its melting point. So your option should be option B. Coming to sixth one, HRC fuse require dash maintenance. The options are less, more, no, very high. When I was explaining you the advantages, I told you they require no maintenance because there is no question of maintenance at all. As soon as the fault occurs, the fuse will blow out. So you have to replace by a new one. So your answer should be option C, no. Coming to seventh one, HRC fuse does not deteriorate with option A, operation, option B, fault, option C, age, option D, none of these. So your answer is option C, age. They do not deteriorate with your age. That means they do not lose their qualities or standards as they are kept for a longer time also. Coming to your next MCQ. Under normal load conditions, the fuse element carries the normal current without option A, heating, option B, cooling, option C, overheating, option D, conducting. So your answer is option C, overheating. Under normal condition, it carries the normal current without producing any overheating. Next, ninth MCQ is the space within the body of HRC fuse surrounding its element is completely packed with the option A, zinc powder, option B, filling powder, option C, talcum powder, option D, any one of the above. So it should be option B, filling powder. Coming to your 10th one, HRC fuse have dash speed of operation. I told you when I was explaining your fuses, as soon as the fault occurs, they blow up. So the options given are high, low, moderate and constant. Your answer should be option A, high, because as soon as the fault occurs, right, heavy current flows to the fuse element melts and it break opens the circuit. That is the reason your answer should be option A. So these are few MCQs just to brush up our memory what we have studied, whether we have understood or not. Let us try to see the descriptive questions which usually come from this topic for examination. The first MCQ question is, explain the construction and working of HRC fuse. So this is the most commonly appearing question in the question paper. Here you have to write both the construction and the working along with the sketch. So the sketch will also have weightage of marks. So you have to write the construction in a separate paragraph and working in a separate paragraph. So usually it is asked for 5 marks. Coming to next question, list any 5 merits of HRC fuses. So we have listed more than 5. We can choose any 5 and write those 5 merits when this question is asked. It is a 5 mark question. So each merit carries 1 mark. So 5 merits, you will be scoring 5 marks. Coming to third descriptive question, list the demerits and applications of HRC fuses. So you write the demerits as well as applications what we have listed. So out of these 3 questions, the first question is the most commonly appearing questions in the question paper. When you look at the previous examination question papers, the first question has appeared almost all the times in the previous examination. So with this, I hope all the contents of this session are clear. How to answer the examination questions also I have given you tips. Try to follow these tips. It will be helpful. And the references we have given here. With this, we come to the end of this session. I thank each and everyone who has given me this opportunity to deliver this session in a successful way. Thank you.